Following on from a recent video, I received a comment from one of my viewers called Hydromakers, and what he was asking was if I could make a video detailing how to create packages for the APT packaging system that the Raspberry Pi uses. Now, if there's one thing I love receiving on this channel, it's comments and suggestions about other videos to make. So thank you, Hydromakers, and let's go take a look at how to create DEB packages for a Raspberry Pi, right here on Jeff's Pie in the Sky. Hello once again, Pi geeks and techno nerds all over the world. My name's Jeff, and I'm an IT professional who's been in the industry for over 30 years. I've been using Raspberry Pi since they first came out, and I wanted to share with you some of the things that I've done over the years. If you like what you see on this channel, please hit that thumbs up button, subscribe if you want to see more, and hit that notification bell so you can be told when I put a new video out. Let me know in the comments how you get on with this video, and if you've got any other suggestions for videos that you'd like to see me make in the future, put those in there as well. All of this interaction helps the channel enormously. I'm trying to get to 5,000 subscribers by the end of the year. So all of the comments, the subscriptions, the thumbs up, any interaction with the channel whatsoever really helps with that. And I really appreciate each and every one of you. So what is APT, an APT packaging system? Well, it's the system used by Debian Linux distributions to do their package management. So when you go to update your operating system or install anything new, you'll typically be using APT to do it. Now, APT is based around the use of DEB packages. These have a .deb extension to their file name. Now, when you create one of these packages, it actually gives you a lot of flexibility, as well as being able to just simply copy files into the locations that you want them to live in. The system also gives you the ability to write custom scripts. And these can be run before the installation, after the installation, before you go to remove the package, and after you remove the package. And so it gives you complete control over the system. Now, there are a few limitations there, but there aren't really many. The fact that it gives you these hooks to allow you to really customize the installation and make it work on your system is really powerful. Although, bear in mind, it is also a bit dangerous. When you go to install packages, you run apt with sudo privilege. And this means that when these scripts are executed, it's done with super user privilege. So you can also do a lot of damage to your system as well. So just be careful. The other really nice thing about these DEB packages is that you can specify within their metadata any dependencies that you need. I'll show you a demo of this later on. But the concept is, if your package needs another package in order for it to be able to run, you can specify that as a dependency. And when apt is going to install your package, it will take a look at this and it will know it has to install the other package first. So you can get a lot of confidence that when you go to install your package, all of the software that it needs to be installed on your system will be present. If any of those dependencies are unavailable, it won't go ahead and install your package. So now we have all of that background, let's actually go off and create a simple package. So here I'm logged into a Raspberry Pi 4 and I've installed on it Raspberry Pi OS 64-bit Lite. Now, even though I'm running this on a Pi 4, you can do any of this on any Raspberry Pi from a 0 all the way up to a Pi 5. The only Raspberry Pi where this isn't applicable is a Raspberry Pi Pico, because those microcontrollers don't really run a traditional Linux operating system as such, and so they haven't got all the hooks that you need. If we look at all of the commands that are available to us that begin dpkg, there are two that we actually require for the package building process. The first of these is dpkg-deb, and this is the application that's used to actually build your packages. The other one is dpkg-name, and this is used to automatically name your package so it features the version number and the machine architecture that it's targeted for. Now, if you install Raspberry Pi OS, either the full desktop version or the Lite version, you get these tools for free. So there's nothing extra that you need to install. in order to be able to create .deb packages that you can then install with apt. So let's create ourselves a simple package. The first thing I'm going to do is just create myself a working directory. And now I'm inside that. Now after this, I want to create another directory within here that is going to be named the same as the resultant package that I want to create. So in this case, I'm going to create a directory called pits-sample, as that's going to be the name of the package that I want to create. Now I'm in that directory, we can start creating the files that we actually want to install. Now you can think of this directory as representing the root file system of your target device. In this example, I just want to create a simple text file and have that install under /var/tmp. So if I create a var/tmp file system right here, that will be representative of /var/tmp on my target box. In here, I'm just going to create a very simple text file. And in here, the text is obviously completely arbitrary. After this, I just want to move back to that pits-sample directory. If I run ls-al now, you can see that we now have a directory called var, a directory called tmp under there, and a file called hello.txt in the tmp directory. The next thing we need to think about is the package metadata. Now, what do I mean by that? This is actual information about the package that you need to provide to the apt packaging system. And we do that by creating a special directory called Debian, all in capitals. And then within there, we create a file called control. And this is the package metadata for this particular package. Against a tag called package with a capital P, I provide the name of the package that we want to create. I can then provide some version information using a version tag, and the machine architecture, which is really important. Obviously, there are Debian-based Linux distributions for all different types of platform, and this could include your normal home PC that is most likely running on either an Intel CPU or an AMD CPU, but the architecture would be x86_64. Here on a Raspberry Pi, we have an ARM-based CPU, and specifically a 64-bit variant. So we have to specify ARM64 as our machine architecture. This way, there's no chance of us getting confused and trying to install the package on an architecture that doesn't support it. We then provide a maintainer tag and just provide an email or some kind of ID to indicate who looks after this package. So if you need support in any way, you know who to go to. You can then provide an arbitrary description about the package. And here I've just said that we're creating a sample apt package. When you're done with all of this, just save that out. The next bit of the process here is to actually build our package. And we need to do that in the my sample package directory, i.e. just above our package directory. So if I do a directory listing in here, all I can see is that one subdirectory that contains all of our package information. All we have to do then is run the dpkg-deb tool. We specify a -b option to say that we're building the package, and then we just give it the name of the directory that contains all of the package information. And that takes pretty much no time at all. Doing a directory listing, you can see that it's created our deb package here. Now I could go ahead and just install that, but there is one other thing that I want to do here. I want to run the tool dpkg-name, and this will actually rename this .deb file. But as a parameter to it, I just provide the name of the file as it currently is. And here you can see that it has renamed the file now, and it includes the version information and the architecture information as we specified within the control file. So now we've built our package, all we have to do is install it. And there are actually two different ways that you could do this. The first way is by running the tool dpkg. And if you give this a -i option to install, along with the name of your package, it will go ahead and install it. And for this very simple package, that would work just fine. However, if it were a bit more complicated and featured dependencies, then the dpkg tool won't resolve those dependencies and download and install those packages. So what I always prefer to do is actually run the apt tool. Now normally apt will work against repositories that are hosted online, but you can get it to work against local files as well. So I'm just going to provide it with the instruction to install and then give it the name of my package file. And it is actually quite important that I do give it a path as well. So I'm just saying it's in the current directory. Now with any apt operation, you have to run it with root privilege, and therefore you have to do this with sudo. And again, just please do be careful with this. Running any script with sudo privilege does give you super user control over your system, and that can be very dangerous. But since we put this package together ourselves, and we know all it does is install a text file, I'm not terribly worried. Now this has thrown a little warning here, complaining that the package file couldn't be accessed by the user apt. But for our purposes right now, this is okay. And if we look in the /var/tmp directory, we now have our hello.txt file. And if I take a look at the contents of that hello.txt, you can see that it's got its lovely little message. And please do hit that thumbs up button and subscribe to Jeff's Pie in the Sky. So it's all well and good building and installing our package, but what about when we want to remove it again? Well, firstly, let's just check on a way that you can prove that your package is installed. If you run apt again, along with the command list, and the option -- installed, this will then give you a list of all of the packages that are installed on the box. If I then pipe the output of that into the grep tool and make this match against my package name, you can see that it's listing our pits-sample package as being installed. Removing a package is just as easy. Once again, we use the apt tool. This time we give it the instruction remove, and then give it the name of the package that we want to remove. It'll ask us if we really want to do this, to which I'll just say yes. And that's now removed that package. And if we look once again in the /var/tmp directory, you can see that our hello.txt file is no longer there. So now we've covered the basics of creating a simple package, building it, installing it and removing it. Let's look at some of the more complex tasks. You may remember me mentioning earlier the fact that you can have these customization scripts run as part of your package. If we go into the Debian directory underneath our package directory, i.e. where the control file is, there are 4 different files that we can create in here. And these files are preinst, that runs prior to your files getting installed, postinst, that runs after your files are installed, pre-rm, that is run before your files are removed, and post-rm, that is run after your files are removed. So if you need to do any special processing at each of these stages, you can use these scripts to create that behavior. So firstly, let's take a look at the preinst script. Now here, I've just made the contents largely empty. It just says that we want to run a bash shell, and then I'm just exiting with a status code of 0, which would indicate success. Exiting with a status code of non-zero would indicate a failure. And if any of these scripts exit with a non-zero return code, it will stop your installation or your package removal from proceeding. Now there is a certain amount of danger there, especially when you look at things like postinst and post-rm. Since these run after the actual install or remove operation has been done, if they fail for whatever reason, your files have actually already been installed or removed. So you do have to be quite careful with these scripts and what they do. So for all of these scripts, preinst, postinst, pre-rm and post-rm, I'm going to make them all do exactly the same thing. I'm just going to make them output a message saying that it's looking for the hello.txt file, And then it's going to do a directory listing of the /var/tmp/hello.txt file. So if that does exist, it will show that as output. If it doesn't exist, then it will come up with a message saying no file or directory. So here I've just literally duplicated the contents of that file into all of the different scripts. I then need to run the chmod +x command along with the file names of my 4 scripts, and this will make these executable. And if I do a directory listing now, you can see that they're all highlighted in green, showing that they are executable. Moving into my control file, I've just upped the version to 0.2. Although given we removed the old version, this isn't strictly necessary. After this, I'm just going to rerun dpkg-deb to build the package again, and dpkg-name to rename it. And now in this directory, we have our new package. The old package is still here just purely because we never deleted it. So now if I run apt install to install our package, we now have this message here that is the output from our pre-inst script. And as you can see, at that point, /var/tmp/hello.txt did not exist. It then goes ahead and actually unpacks the package, and this will create our file to get written. We then have the post-inst script getting run, and now you can see that our /var/tmp/hello.txt file does now exist. And indeed, we can show its contents. So now if I go to remove the package, and we confirm that we want to do that, here we can see the output of the pre-rm script where our file still existed, and then the output from our post-rm script that shows that the file is no longer present. And indeed, if we take a look in the /var/tmp directory, our file isn't there anymore. The next thing we're going to look at is how dependencies are managed. Now going back here into the Debian directory, and in the control file, I've increased our version number once again just so that there's no ambiguity, but I've added this extra tag at the bottom called depends. And whatever you list after this tag is treated as a list of packages that you want to install as a dependency of this package. Now in this case, I want to install the Apache 2 web server, and you'll see why in a minute. Now just specifying the package name here will result in it just trying to find whatever the latest version is. If you wanted a very specific version of a package to be installed, you can use this equals nomenclature in brackets here, along with the specific version number that you want to install. If you want to install a version that's greater than or equal to a specific version, then you can use the greater than or equals sign. And apt will work all of this out at the point where it goes to install your package. So it will look for an Apache 2 package where its version number satisfies the constraint that you've put in. If it can't find one, then your package installation will fail. In my case here, I don't care about versioning. All I want is any version of the Apache 2 package. So I'm just going to save it out like this. Now the other thing I've done here is rather than install to the /var/tmp directory, I've created a /var/www directory instead, with an HTML directory under that, and I've changed my hello.txt to index.html, and I've changed our simple message text so that it's still displayed, but it's now provided inside some HTML5 markup. I've now used our normal dpkg-deb and dpkg-name commands to build and rename our package. And now we have version 0.3 of our package available. So now let's go and install it. And here you can see what it's going to install is actually quite a big list of packages. Our pits-sample package here listed Apache 2 as a dependency, but Apache 2 has a load of other packages that are dependencies as well. And that just includes this SSL cert package listed at the end there. So apt has been able to figure all of this out, and now it will go ahead and install all of these packages in the correct order. Now, apologies, one thing I completely forgot to mention there was I also updated all of our custom scripts so that it was looking for the index.html file rather than the hello.txt file. But you can see here, this is the output from the pre-inst script where it's saying that that file doesn't already exist. Once all of these other packages are installed, it then runs the post-inst and now the file is there. But you can see it's also set up the Apache web server and all of its dependencies. And if I open up a new browser and I navigate to the default web page on our Raspberry Pi, you can see that it shows our message absolutely no problem. Now, one thing that may seem a little bit strange here is if I now go ahead and remove the PITS sample package, it will say it's only going to remove our package. It's picked up that all of the dependencies aren't referenced by anything else, but it won't automatically remove those, at least not as part of this command anyway. So if I go ahead and I remove our package, then once again our pre-rm script got run, where we could still find our index.html file, and our post-rm script ran, where it can no longer find index.html. Now if I want to clean up all of those other dependent packages, I can just do exactly what apt told us to do, and run sudo apt auto remove. And what this will do is, if there's a package that is no longer referenced by any other package, and it's not in use, then apt will detect it as removable. So in this case, these packages were only installed on the box because they were referenced by the PITS sample package. They weren't required by anything else on the operating system. And so by running auto remove here, it's flagged all of those as being viable to be automatically removed. And now I've done that, our web server is no longer on the box. And so there you go, a really simple mechanism that you can use to create your own packages for your Raspberry Pi or other people's Raspberry Pis. Now, if you want to publish packages, you can create things called apt repositories to host them on. And the location of these repositories is configured within apt itself. There's a configuration directory called /etc/apt. And in there's a file called sources.list. And by default, this contains the URLs of all of the apt repositories that it needs to look in for any packages that it wants to install. There's also a directory under there called sources.list.d where extra repository lists can be provided. Now, like I say, you can create your own repositories, since it's unlikely that you'd have permission to be able to use any of the public ones. Now, creating those repositories is probably out of the scope of this video, but if you'd like to see how to do it, let me know in the comments. But that's it for this video. Once again, if you like what you see here, please hit that thumbs up button, subscribe if you want to see more, and hit that notification bell to be told when I put a new video out. Let me know in the comments how you get on creating packages for your apt system. And if you want to see me do a video on creating apt repos, or indeed if you've got ideas for any other videos that you'd like to see me do, put those in the comments as well. Thanks so much for watching till the end, and until next time, bye for now.